Hey, 4.6 trigonometric identities. So the objective to the following question types is to try and prove that different trigonometric equations are true. Okay, so that's the purpose of the following. Okay, and we do this so by showing that the left-hand side equals the right-hand side. Okay, so using algebraic methods such as here's some factoring, expanding, using common denominators, and then in the following two simple trigonometric identities. So this is like substituting them in. Subbing in. Okay, so there is something called the quotient identity. And what that one is tan theta equals sine theta over cos theta. Okay, likewise, tan squared theta is sine squared theta over cos squared theta. Okay, and then if you move the cos up and the tan down in either of these, okay, we'd have cos theta equals sine theta over tan theta. And if you just cross multiply that tan up, we would have sine theta being alone and then equals cos theta tan theta. So just, this is the only quotient identity here, and all the other ones we're just rearranging. Okay, so let's go ahead and let's prove the quotient identity. So if we have sine theta over cos theta, well, we know that this is opposite over hypotenuse, and then that's divided by, what's cos? Adjacent over hypotenuse. So we would rewrite this as opposite over adjacent times the reciprocal, so h over a. These h's would cancel out, and we would be left with o over a. Okay, well, what's o over a? Tan theta. So sine theta over cos theta, this is just showing you that if we divided over h divided by a over h, we would actually get o over a, which again is tan theta. The second identity that we're going to touch on in this course is the Pythagorean identity. Okay, and then this is sine squared theta plus cos squared theta equals 1. Okay, the two identities down here are just derived from rearranging sine squared plus cos squared equals 1. So what happens is if we have 1 on the right hand side and we bring over cos squared, we would get sine squared equals 1 minus cos squared. Okay, theta, of course. And if we brought over the sine squared theta, we would get cos squared theta equals 1 minus sine squared theta. Okay, all of these are equivalent. So here are some tips and tricks that might help you to prove trig identities. Okay, so here's the rule. You cannot move terms across the equal sign. Okay, just work with each side separately. So all the way down your page, you should see a bunch of equal signs. Okay, keep the left side as the left side, keep the right side as the right side. Start with the more complicated of the two sides and try to express each side in terms of sine and cos only. Okay, so use the quotient identity whenever you see tan theta. Okay, number 4, sometimes you'll have to stop working with one side and then go to the other side and manipulate the other side. Okay, in order to show that both sides are equal. I would say expand and simplify if possible. Okay, just remember sine x or sine theta plus sine theta is 2 sine theta. Sine theta times sine theta is sine squared theta. Okay, and you're going to look for situations where you can combine terms by using a common denominator. Okay, that's another one of those cheats, common denominator. Also watch for factoring possibilities, especially common factoring. Difference of squares comes up a lot. Okay, and trinomial factoring. And then look for situations to use any versions of the quotient or Pythagorean identities. Work on proving the following trig identities. Okay, so we have cos tan over sine equals 1. Okay, always start with the more complicated side. So I'm going to rewrite tan as sine over cos. So cos theta times, and tan is sine theta over cos theta, right? This one I substituted in for tan, all over sine theta equals 1. Okay, well, in the next step, I'm going to cancel out these cos thetas. Now, all that I have left is sine theta over sine theta equals 1. Well, sine theta over sine theta does equal 1. So that one's correct. Left side equals right side. So this is indeed a trig identity. Okay, B. Again, start with the more complicated side. I'm going to say the more complicated side is the right-hand side. So I'm not even going to write out cos theta. I'm just going to start with the right-hand side here. So let's go 1 over cos theta. And I'm going to sub in sine over cos for tan. So I have sine theta times sine theta over cos theta. Okay, so I get 1 over cos theta minus, this is going to be sine squared over cos theta. Well, we know that we can collect the numerators here. So I get 1 minus sine squared theta all over cos theta. Well, we know from the Pythagorean identity, 1 minus sine squared theta, we can actually substitute in cos squared theta. Okay, it's still going to be over cos theta. So now the question is, like, how can we get these equal? Well, cos squared theta, the squared and one of the coses will cancel out, and we're left with cos theta equals cos theta. So this is a trig identity, and we can say left side equals right side. Okay, C. So for a question like C, I feel like the left-hand side is a little bit more complicated. I'm just going to go ahead and distribute, like FOIL. 1 times 1 is 1. 1 times negative sine theta is negative sine theta. You see how these are a difference of squares, right? 1 plus sine theta, 1 minus sine theta. Sine theta times 1, so plus sine theta. And then sine theta times negative sine theta. So that's going to be negative, like minus sine squared theta. Okay, these two signs in the middle cancel. So negative sine theta plus sine theta, those go away. We're left with 1 minus sine squared theta. Okay, now, how are these going to be equivalent? Well, we can use Pythagorean's identity, PI, okay, to substitute cos squared theta into the left-hand side. Okay, so this is indeed a trig identity. Left side equals right side. Okay, and then D. So we have sine squared theta over 1 minus cos theta equals 1 plus cos theta. Okay, so I'm going to substitute in 1 minus cos squared theta in the numerator all over 1 minus cos theta. Okay, I know, especially from like the previous example, okay, I can actually factor this. This is difference of squares. So how you would factor that is you would get 1 plus cos theta and then 1 minus cos theta. And that's all going to be over 1 minus cos theta. Okay, these 1 minus cos thetas cancel, and I'm left with 1 plus cos theta, and then that equals the right-hand side, which is 1 plus cos theta. Left side equals right side. Okay, for E, we have tan squared theta minus sine squared theta equals sine squared theta tan squared theta. So first what I'm going to do is I'm going to get all these tans out of there. I'm going to sub in with the quotient identity. Okay, so I'm going to go ahead and sub in sine squared theta divided by cos squared theta Okay, and then that's still going to be minus sine squared theta equals, and then I'm going to go sine squared theta times sine squared theta over cos squared theta. Okay, so now what I'm going to do is I'm going to find a common denominator for the first two terms. So since sine squared theta is over 1, what I'm going to do is I'm going to choose cos squared theta to be my common denominator. Okay, so I'm going to multiply this by cos squared theta over cos squared theta. So essentially what we get is sine squared theta minus sine squared theta cos squared theta, and this is all going to be over cos squared theta. Okay, for this side, I'm gonna leave this for a moment. I'm gonna see what I've come up with on the left-hand side. Okay, so what I'm gonna do is I'm going to factor out the sines. Well, sine squared theta. Okay, and when I common factor out sine squared theta out of these two terms, just in the numerator, I get 1 minus cos squared theta, all over cos squared theta. Okay, so this is looking more like this. So I have a sine squared theta, I have the same denominator. Now, this part, what I'm going to do is I'm going to use the Pythagorean identity, and I'm going to go ahead and I know that 1 minus cos squared theta is just sine squared theta. So I'm going to go ahead and sub that in. Now, on the right-hand side, going back up, I'm going to collect sine squared times sine squared is going to be sine. Oh, well, we can write it sine to the 4 theta over cos squared theta. Bring this all the way down. These two also simplify to sine to the 4 theta over cos squared theta. Okay, so we could have either simplified it as sine to the 4 theta over cos squared theta, or we could have left it like this and just brought the right side down. Okay, F. So I see 1 over 1 minus sine theta minus 1 over 1 plus sine theta. And if you think about it, these, even though they're subtraction, I automatically think in my head, oh, okay, so these are like the components of difference of squares. Okay, and then I have 2 tan theta over cos theta. So what I'm actually going to do here is I'm going to find a common denominator. So my common denominator is going to be 1 minus sine theta, bracket, 1 plus sine theta, bracket. Okay, so on the left-hand side, I'm going to color on this, 1 plus sine theta over 1 plus sine theta. That's what I multiplied the left, it's not the left-hand side, that's what I multiplied this term by. Now the second term, after we subtract, I'm going to multiply it by 1 minus sine theta over, and then the denominator 1 minus sine theta. So what we have here is 1 plus sine theta minus, remember when there's a minus sign, you have to put this in brackets if it's two terms, 1 minus sine theta. Because here we have to distribute this negative sign into the bracket. So I get 1 plus sine theta minus 1 plus sine theta. Okay, if you notice the ones cancel and we get, and I'm just copying down the denominator. Okay, those cancel and we get 2 sine theta over, I'm going to leave this denominator right now because I'm thinking difference of squares, expand it. Okay, but I'm going to see what happens with the right hand side. So this is going to be 2. I'm going to get the tan out of there. 2 sine theta over cos theta. Okay, and I can write this, I can write it over cos theta, but what I'm going to actually do is I'm going to take this and I'm going to write it as divided by cos theta. Okay, so we have 2 sine theta over cos theta times, okay, Remember, we can't divide fractions. We have to multiply by the reciprocal. So times 1 over cos theta. So we have 2 sine theta over cos squared theta. Okay, so I was right. We have to do difference of squares on the left-hand side. You notice that nothing has come over that equal sign. Okay, when we expand this, we get 1 plus sine theta minus sine theta minus sine squared theta. Those middle terms cancel out. We're left with 1 minus sine squared theta. I'm going to go ahead and sub in Pythagorean's identity. So I get 2 sine theta over, so instead of 1 minus sine squared, I'm going to put this over cos squared theta. And now, left side equals right side. Okay, so for both of those, we can put left side equals right side. Okay, example 2, prove the following trig identities. Okay, so this one's a little bit like the last one, except for we're dealing with the squared. So I'm just going to just delete A, so we have some space to work in, okay? So I'm going to find a common denominator between the first two. So our common denominator is actually going to be sine squared x and then cos squared x. Okay, so I'm going to multiply the first term by cos squared x over cos squared x. And I'm going to multiply the second term by sine squared x over sine squared x. Okay, so in the numerator, what we're getting is cos squared x plus sine squared x. Okay, and then I'm going to leave that for 1 second. Now, cos squared x plus sine squared x, we know that this is Pythagorean's identity. So I'm just going to sub in 1 because those are equivalent. Okay, and in the denominator, I get the same thing. Okay, so I can just bring that down. 1 over sine squared x, cos squared x, left side equals right side. Okay, example 2, we have sine squared plus cos squared plus tan squared equals 1 over cos squared. Okay, so when we take a look at this, we can actually see that cos squared x plus, sine squared x plus cos squared x, we can cancel out with Pythagorean's identity, and that just actually equals 1. So now we have 1 plus tan squared x equals 1 over cos squared x. So this tan squared x, I'm actually just going to write as sine squared x over cos squared x. Okay, how did I get that? This is quotient identity. Okay, get all the tans out of there. Now I'm going to find a common denominator. So I'm going to multiply 1 by cos squared x over cos squared x. Okay, so now I get cos squared x plus sine squared x all over cos squared x. Okay, so if we take a look at the numerator again, we have Pythagorean's identity again. So that can cancel out, go to 1, and we're left with 1 over cos squared x equals 1 over cos squared x. Left side equals right side. All right, for C, we have sine x over 1 minus cos x minus 1 plus cos x over sine x, and this is going to have to equal 1. Okay, so I'm going to get rid of the C just for more space. Okay, so what I'm going to start with is I'm going to find a common denominator. Okay, so I'm going to multiply this first term here by sine over sine. Okay, and I'm going to multiply the second term by 1 minus cos x over 1 minus cos x. Okay, so now the entire denominator is going to be sine x bracket 1 minus cos x. Okay, and in the numerator, we'll have sine times sine, sine squared. minus, and then this is going to be 1 plus cos x bracket 1 minus cos x. Okay, I noticed this immediately, difference of squares. So I'm going to go ahead and expand that, and we're going to get sine squared x minus, so this is going to be 1 minus cos x plus cos x minus cos squared x. Okay, and I'm just going to rewrite the denominator. Okay, so in difference of squares, that middle term cancels out. Now, if we think about it, and I'm just going to rewrite this so we can see it, we have sine squared x minus, well, what's 1 minus cos squared x? What can we sub in for that? Okay, so what we can sub in for this is Pythagorean's identity. We're going to sub in sine squared x. Sorry, fill in the right-hand side. Okay, so in the next step, we have sine squared x minus sine squared x. Okay, over some denominator. Well, what's sine squared minus sine squared? It's 0. So 0 equals 0. We don't even have to put this denominator anymore because it doesn't matter. 0 equals 0. Left side equals right side. Okay. Now, D. Sine x over sine x plus cos x equals tan x over 1 plus tan x. So I'm going to just manipulate the right-hand side first, okay? So I'm going to rewrite tan x as sine x over cos x. I'm not going to write it over top because I don't want a fraction over a fraction. So I'm going to write it divided by, okay? But we got to keep this in brackets because it's like the denominator. So it's divided by 1 plus sine x over cos x, right? 1 plus tan. Here's the thing. I'm just going to rewrite the first term here. I'm not comfortable flipping this as it is because we have two terms. So let's find a common denominator. I'm going to multiply this by cos x over cos x. So now I have cos x plus sine x. Do not sub in Pythagorean's identity because these are not squared. It has to specifically be squared for that to hold. Okay. However, now that it's a fraction, I can go ahead and reciprocate it. So sine x over cos x, now we're going to do multiplied by cos x over cos x plus sine x. Okay. So essentially all of this is in the numerator, all of this is in the denominator. If you have to see that beside each other, you can go ahead and rewrite it beside each other. But that's just rewriting it. So check this out. So we're going to cross out the cos x's, and what are we left with? We're left with sine x over cos x plus sine x. Okay? Sine x over cos x plus sine x. So left side equals right side. Okay, last one, E. Again, I'm going to erase the E for more space. Okay, we have 1 plus 2 sine cos over sine plus cos equals sine plus cos. Okay, so this question is quite hard because I don't really know where to start, but I know that we're going to need a common denominator. So why don't we choose sine plus cos as our denominator, and we're going to go ahead and multiply the right-hand side by sine x plus cos x, okay, over sine x plus cos x, and see what happens. Okay, so we're going to have sine x plus cos x in the denominator. This is our numerator. So our numerator doesn't look like the left-hand side, so why don't we try to expand it, see what we get. We get sine squared x plus sine x cos x plus sine x cos x, and then plus cos squared x. Okay, and we still have the same thing on the left-hand side. And this looks a little confusing, but it's actually almost done. Okay, well, what's sine x? What's like sine cos plus sine cos? Well, that's going to be 2 sine coses, right? So 2 sine x cos x. Now, I always put like these bubbles here. What's sine squared x plus cos squared x? We can just go ahead and sub in 1. So it's like plus 1. And we're actually done. These are equivalent. Okay, left side equals right side.